aga-cad is proud to present Panel Packer, a powerful solution for sorting, packing, and loading prefabricated building components. Stack all project elements from assemblies of walls, floors, and roofs to individual structural framing members. Organize items by predefined truck load size or in standalone stacks. Set up, save, and reuse packing configurations. Convenient use of color coding and unique naming ensures accuracy and precision. Optimize packing by organizing panels into bundles based on desired parameters and specifications. Freely define stacking location in relation to the building site. Create drawings for packed panels indicating parameters, size, and location. Organize stacks, truckloads, and bundles by project phase and construction sequence. Interface is easy to use, even for users with little previous experience. So here we have our new tool, Panel Packer. It would typically be used at the later stages of a design phase or entire project. At the time when you already have your wall, roof, and floor frames built, everything is kind of sorted out, and you're just left off with kind of creating stacks of prefabricated components, building components, which you just want to store away somewhere, or you kind of want to plan ahead how they're going to come together on a building site. So the Panel Packer would be used in combination with Sort Mark that will help you create parameter values. Of course, as well with our wood and metal framing suites, Wall Plus, Floor Plus, Roof Plus, and so on. So in this case, we have a sample project which you can download using the eHelp link, download from our website. And in here we have quite a few wall assemblies already created. First thing to note, so under assemblies in our project browser, you can see a large list of wall assemblies. So a couple common things between those wall assemblies. So it is important you kind of work out a system you're going to use to sort your framing, structural framing members as well as assemblies. So in this case, if we select one, we go to comments. So we see that our building is subdivided into units, Unit B and Unit A over here. We also have subdivided by wall assemblies by levels. So there's our level 1, there's our level 2, all the way up to level 4. And also we have subdivided by internal and external walls. In this case, we have internal wall number 3 and we have external wall number 9. So essentially each wall has its unique marking depending on the last 2 digits, but it still belongs to either external or internal category walls. They also belong to a certain level and a certain unit. So that's important that you work out this kind of convention, how you're going to sort your walls, floors, and roofs in the project. And you can do that with Sort Mark. So when it comes to elements numbering, you can select assemblies, and you can select a particular parameter that you want to work out the value for. So for example, comments, or perhaps our host member Sort Mark. So that's up to you. The other important bit is that you sort of designate a phase, your design phase. So in this case, we have transportation phase that we've created. In configurations, you can just allocate a sort of a design phase in which your stacks or packs of panels will be loaded. So in this case, it's our transportation phase. And the other important bit is, well, it's not necessary, but it just brings a lot more clarity into the project, is to work out your color coding for your stacks. So later when we're going to create stacks, we're going to do that, but that's typically done in your visibility and graphics overrides, or perhaps in your view templates in filters section. And you want to create filters which will help you to color code your stacks. Okay, so we'll come back to this later. So once your roof, wall, or floor framing is complete, it is important, for example, with Wall Plus, that you calculate assembly dimensions. And also it's good to calculate framing element mass. So that's your individual structural framing members, as well as entire dimensions for the entire assembly. And once you do that, we'll have information written into specific size and weight parameters for each of the structural framing assembly. And we have assembly length, height, area, wall, and width. And somewhere should be mass is over here. So once all of these things are complete, you move on to packing configuration. So as always, we have configurations, file location, eHEL button, configurations, and then a couple of, well, two ways of packing by selected specifically selected assemblies for walls, roofs, and floors, or pack all essentially. So looking at configurations, so just going to close that. Looking at our packing configurations, I mean, the user interface isn't too complicated, to be honest. So we have some common settings in which we can name stack truck type. So that's something default that we're going to write in. We describe our size and weight, spacing dimensions. So spacing, if there is any, between each assembly that's going to be placed in the pack or stack. Whether you choose to join trucks or stacks or not. Then moving on to stacking loading panels. So 3 tabs, well actually 4. So the 4th one is specifically for structural framing elements. You can also filter out those elements additionally. But for walls, roofs, and floors, you can place it either vertically or horizontally. That's your orientation of your stacks, or how the panels are going to be placed. For external and internal walls as well. You can also combine both external and internal wall stacks. Then, like I mentioned, you choose the specific phase in which you want to place that, and whether you're going to place by separate points, that is, you click more than once, or you click every time you place a new stack, or you place all of them by just single click. And then our filtering, that is stacking loading settings. So like I said, we have comments. So we had those parameters worked out, mark, comments. Framing mass sort mark is exactly the same as mark. So there's actually only 2 that we're using in this case. There may be projects that will just have one sophisticated parameter value that will be sufficient enough to kind of sort out your assemblies. But back to configurations, you will have some default configurations with the sample project, and just with installing the software in your workstation. You of course can remove those, just get rid of those and replace them with your own, rename and save. So back to here, you just filter out specific parameters. So a host number sort mark and comments in this case. So essentially these just represent different filtering rules. So unit B by level, unit A and B by internal and external walls, interior and exterior walls by levels. So we're just using those parameter values to build our sort of configuration. So once you do that, then kind of left off with just packing. So if you go and pack all wall assemblies, now choose from desired configuration. So maybe unit A by level, click OK. Okay, so we have total 168 wall assemblies in the project. We have 88 assemblies without warning. That is 88 wall assemblies have matched our filtering configuration for filtering the parameter values, and 80 have not matched our filtering rules that we set. That is, they probably belong to unit B. Yes, so if you read through, level 1 internal wall panel does not contain split character unit underscore A for parameter with current value. So that's the value we set, and all the units with a different value are kind of left away. And that's why we want to have only unit B wall assemblies. So we can just skip all of those. And then it's going to kind of ask you to place your stacks. So if you just select sort of an empty space, you can also go to a plan view to be more precise and just locate where you want to stack your wall assemblies. So now it's in the process of stacking of unit A walls by level. So I have one stack. That's stack number 1. We have 3, 5, 7. Okay, 2, 4, 6, and 8. Okay, so let's see. Just select a single stack. So there's a generic model family that comes together with a tool. It's located in your library, local hard drive library, when you install the panel packer on your workstation. So that's the family it's using. So it's taking the assembly dimensions and weight, and it's kind of sort of shaping this generic model family to match, in this case, level 1 external wall number 22 wall assembly size and weight. So I have mass, and we have assembly name, and all these parameters. So if we're able to find, level 1 external wall 17, so I believe that's our level 1 stack, external wall 17. I mean, it could be just, yeah, level 1 external walls. Okay, so we know that this, we just isolate those two elements. Okay, so we know that level 1 external wall 17, that's the representation of this wall assembly. So in terms of size and weight. So that's over here. Yeah, so let's have a look. So now, once you stack your walls, roofs, or floors, stack your assemblies, the software will populate your families of generic model, your assembly families, as well as your structural framing families with 4 parameters. And those are truck type, truck column number, and row number. So this will allow you to recognize where each panel is located. So for example, we know that this assembly belongs to default truck stack, so that's what we described in our configurations. Okay, we know it's column number 2, right? So in this case, our columns are placed horizontally because we're stacking horizontally. My mistake. So the columns are vertical in this case. So that's our column number 2. Okay, let's go back to the parameter. Column number 2, number 1, row 4. Okay, so column 2, truck number 1, row 4. Okay, so I believe that's 4 from the bottom, so that's row 1, row 2, 3, that's row 4, and truck number 1. Let's see that. Truck number 3, truck number 2, and that's our truck number 1, row 4 from the bottom, and column number 2 from the left. There's our there's our wall assembly packed in this stack, basically. Okay, and based on those parameters, I mean, we can also recognize our structural framing members because they also have those parameters, like I said, so we know which assembly it belongs to, and we know where is the particular assembly. So I'm looking at unit B, which we haven't packed, so those parameters are actually empty. But if I moved on to unit, unit A, if I highlight my structural framing member, parameters are filled in, and I know it belongs to a specific assembly. The assembly is represented in a specific location in relation to each individual stack. Okay, so based on those 4 parameters, the next thing you would want to do is go to your view template and work out your filter rules, your filtering. Okay, so rule-based filters. We're gonna color code our stacks. So panel stack by truck number. Well, in this case, it was meant to have 10 stacks, but we have 6 stacks, or definitely less than 10. But basically, I'm setting up my rule based on this parameter, and when the number is equal 1, that will mean I'll have this rule based on the parameter and specific value. So if I select OK and just add, so let's see, 1, 2, 3, 4, 5, 6, 7, 8 stacks. Okay, yeah, so that's truck number 8. Okay, so we need to add 8 filters, so 8 should be enough. Add 8. Yeah, I guess the other good thing is to work out your color coding, so just assign colors, whatever those colors may be. Okay, we know these are visible, and we have colors assigned. Okay, so now our stacks are colored based on the truck number, and the walls that we have sorted out also have been colored based on TR number. Okay, and I believe unit B assemblies are colored because our structural framing members still contain the TR number, which I haven't removed coming back from the sample project. So if you remove these, or if you start from fresh, your unit A assemblies will be colored. Or instead of that, you can just make your filters more sophisticated. If you go to filters, edit /new, and work out another rule. So you just add rule. We know our comments have also values, so unit A and unit B. So if that equals to unit A, okay, and just probably have to do for all of these, and there we have it. So the walls belonging to unit B are now excluded from the stacks. However, these couple of walls actually belong to they have nothing. Okay, so these are intermediate between units A and B. So, I mean, you can just remove those if you like. And removing stacks or individual assemblies is just simply using Revit functionality. So you just delete those. And furthermore, I mean, going in the plan view, you can also have information written here. You have type parameters for each of the, for framing assembly family, and you can change certain type parameters of that family. But the great thing is that you can just you can move the stacks manually. You can place them on top of each other. You're just using Revit functionality. Okay, so that's from modeling to framing to creating assemblies, getting drawings, working out your naming conventions for your parameters, and then stacking your walls. Okay, so now once our walls are stacked, in this case, that's a different kind of stacking. On view. Okay, just stacks. So in this example, I have stacked according to a different configuration, and I have more stacks. I have 10 in this case, and color coding is also working fine for me. So at that point, you can move and relocate your stacks, place them in different phases, but also, create a legend, I guess, to represent the color coding, and also create drawings. So whether drawings are represent the way how stacks are going to be brought on site, or they just some sort of generic drawings to just represent how many assemblies you have, or just a sort of visual representation. But it's quite precise as well. I mean, you can pull out schedules of your assemblies. You can filter out those as well according to level, unit, internal, external, etc. We have all the key information, so sizes, count, mark value, and you can also add the weight value to those schedules. So that's pretty much it for creating stacks. I guess once the project is framed, you can also have different kinds of assemblies for material takeoff, framing schedule, etc. So that's just a standard functionality of wood and metal framing suite.
aga-cad, building BIM together.